All right, it's really nice to see everybody here today. Thank you so much for coming along. I'm Sarah Cowie, standing in for Amy Odom, sorry, and I'm here just to chair the session. I'd like to introduce you to our panelists today. So we have Andy Craig from SUNY Upstate Medical University. We have Shawn Gilroy, who is joining us from Louisiana State University, and we have Sam Morris joining us from also Louisiana State University. Our discussant today is Suzanne Mitchell from Oregon Health and Science University. Now, although we have a fabulous panel and a brilliant discussant, we would really love audience input too. If we can make this one giant discussion, that would be really fabulous. So I will hand over to our discussant now. Welcome, Suzanne.
Thank you, Amy. Thanks, Sarah, so much. I know that it's very untraditional to have the discussant say anything first, but AI and computational approaches are somewhat non-traditional in behaviour analysis. So I just wanted to say a few words at this outset to sort of set the tone and where this whole thing came from. So started having some discussion, I guess, with Andy and with Chris Frank about AI, the role of AI, also the role of computation in journals, behaviour analytic journals. I should say that I'm the current editor of SQAB, and traditionally there's not been any statistics and this and that, and we're getting more statistics, more sophisticated statistics. We're also seeing simulations. I am really open to let's have some great statistical approaches, let's have some simulations, but let's do them right. And so more recently we've also been thinking about the role of AI and to what extent can you use AI and it still be your paper and not the ChatGPT's paper. And so SQAB is interested in thinking about guidelines for what are acceptable uses of AI and how to acknowledge AI was used, because we want to be transparent and to make sure that people understand, this conclusion, this beautifully worded conclusion or summary was generated in collaboration with AI language learning models. So we thought this panel would be a great place to start a conversation amongst our community and to start thinking about these things. And I'd like to solicit any thoughts from the audience, either in this panel, or if you want to email me, it's easy to find my information, Suzanne Mitchell. But I'd be very interested to hear your opinions as part of the field. But right now, we're going to hear from these guys. Thank you.
Sure. You have an introductory spiel?
All right. Yeah, I'll jump in.
Yeah, do it.
Shawn Gilroy. I guess my contribution to this panel is more in terms of the kind of general statistical implications that we're kind of facing now, that ChatGPT is so accessible, and I think, and I guess just to kind of put a couple of things that are on the forefront of my mind, for the folks that are pursuing accreditation through modern standards and the expectations that programs are supposed to cover applicable statistics to behavior analysts without necessarily outlining what that should be or where that expertise comes from. I think a lot of folks right now are exploring AI to make up for that, so that's a lot of what I'm hoping to kind of speak to today.
Yeah, Andy Craig. I think my perspective is that of a current SQAB AE. So Suzanne and I have worked really closely on questions related to all of the above, everything that she just mentioned. Because we often work with papers that have very sophisticated statistical methods embedded. What is the role of those very sophisticated statistical methods in JAB? How do we, in an informed manner, ensure that those statistics are being used appropriately, ensure that ChatGPT is not running all of the statistics that are being incorporated into manuscripts? To set a little bit of context for this conversation, it really sort of developed around papers that we were getting at JAB that strictly use simulation of data to provide the structure for the entire manuscript. And JAB has this emphasis on the behavior of individual organisms. What does that conversation look like when there aren't any actual organisms in those papers? So I'm really interested to dig into some of these questions with all of you today.
Sam Morris, I'm excited about these things to talk about it with you guys, but I think my main things, in addition to what we've been mentioning up here, I have gotten a chance to do a little bit of simulating data to try to inform some of our experiments or guide our experimentation. And I, so far at least, have found that process to be very useful. So I wanted to touch on the utility of simulating data and informing or guiding experimentation, but then also some methods that I think maybe could get a little bit more love from behavior analysts relating to simulating data to sort of analyze our results, either like hypothetical distributions to sort of compare our data to, or simulating rearrangements of our data to quantify things like differentiation or other measures of effect size. So those are the things I'm hoping to talk about. But maybe now would be a good time if anybody's interested to ask questions from the audience. Otherwise, we'll dig deeper into our spiels. Anybody have any questions? Something you want to contribute?
Simulations of behavior.
Okay.
There's a difference between a simulation of behavior and the generation of a prediction from a theory, where that prediction produces behavior, theoretical behavioral outcome, to compare to empirical behavior. That's not a simulation in the sense of sort of artificially creating behavior. The way to think about a simulation, in my view, is the famous example of the remuneration of starlings, where starlings go out and you can look it up on YouTube, and they fly around and stuff. You can simulate that by taking artificial starlings and saying, don't collide with other birds, stay X feet away from the nearest birds, and you can get a simulated thing that looks similar. But they're not asserting a theory about how the flock is actually working. If you have a theory about how a flock is actually working, and the theory is such that it produces a behavioral outcome to compare the data, that's not a simulation. So I think we shouldn't use that word in that context.
I see. Okay. So I think there's a couple of points that I'm thinking of, at least. So one, just I think everybody could hear. I don't need to try to reiterate that. Thankfully, that would be a tough task. But something that I think of with simulating versus a theory, in both cases, it seems like we have some low-level rules that are being used to either construct a theory, in the case of complexity theories like the ETBD or other genetic algorithms and things like that. Those have low-level rules that are then used to generate data, much like in simulations we may construct low-level rules or characteristics of the distribution that we're looking for to then simulate data. To me, it seems a difference in like the direction that we're coming at it from, maybe more so than a difference in process, but I'd be interested to hear what other people have to say.
Yeah, I mean, my thoughts on this topic sort of extend beyond just simulation, whatever word we want to assign to it, and more to the quantitative analysis of behavior in general, right? Because the quantitative analysis of behavior, the bright, beautiful, shiny thing about it is that we can use data to hold fire to the feet of the theory. And in the case of the evolutionary theory of behavioral dynamics, you consistently do that, right? And that's the goal of those quantitative models. They make such specific, testable predictions that you can reach into the literature, find those data, see how the prediction accords with the data that we have. If we don't have those data, generate those data, right? When I bring up issues with simulation, we are talking more about data sets that are, data points randomly drawn from a normal distribution with a known mean or known standard deviation, and those are our data, right? With no underlying logic as to how those specific distributions correspond to the data of living, breathing organisms. So as you're saying, Jack, there's no underlying mechanism or rhyme or reason to that specific set of rules that you're using to simulate. But I totally agree with your point that that's what we're doing with the quantitative analysis of behavior in general. Yeah, it's a very powerful way to go about science.
Yeah, and I think it's interesting, especially, I think I want to invoke simulation, especially in those cases where we no longer have data as a point of comparison, that it's not, we're trying to generate behavior that looks like the results of a given experiment, but then I think there are especially exciting times where now the behavior that's generated or simulated or whatever word we want to use is extending beyond data that we have available to us. I think that's a very exciting but also kind of complex thing, like how to deal with that or how to use it to guide the experimentation. I think Andy's point is a good one, though. If the predictions are quantitative in nature or precise in nature, it really provides a nice opportunity to potentially even falsify, right? Like the model or the framework that was used to generate the data. So I think those are especially valuable opportunities, whereas they might be. It looks like Jack has another question. No, you can say as much as you want.
That is that it's important for theory, certain kinds of theories, like complexity theories, can generate behavior that has not, in fact, ever been observed in live organisms. That's called a second stage prediction of a theory. It's a very, very powerful test of a theory. It's not a simulation, it's a prediction of what's going to happen if you run your organisms like I ran my artificial organisms. And as I've said before in papers, the most famous second stage prediction in science is the prediction of the existence of the planet Neptune, which was predicted because of perturbations in the orbit of Uranus. And those perturbations, according to Newton's laws, couldn't be there unless there was a particular planet at that location and that mass. And you turn your telescopes and you saw it, and there was the planet Neptune. That's a second stage prediction. That was made before anybody ever saw Neptune. So it's a second stage prediction of a theory. It's not a simulation. It's an important statement that allows the theory to be tested very, very dramatically.
I mean, from my perspective, I totally agree with the point that you're making, Jack, but from my perspective, if a manuscript were to come through JAB with that sort of a prediction, I would also expect there to be some data testing that prediction, right? I don't know that it is absolutely the case that, you have to have those data in order for that sort of a prediction to be something that could make it through the editorial process, but it certainly would be a stronger demonstration. Like, here's this completely novel prediction that no one has ever, there's no existing reason for us to logically believe that should be the outcome aside from the specific mechanisms evoked by this theory. Boom, there are the data showing that actually comes to fruition. That can be an incredibly powerful source of support for those specific arguments.
I totally agree with that. However, it's much scarier for the theoretician to put out the prediction without the data. Others who don't like the theory can pounce, and run the experiment and try to disconfirm it. So it's a lot scarier to do it that way. But I agree with what you're saying. It would be good to.
Yes.
Also, the other thing is, if you have the data, you make the prediction in your lab, and then you run the experiment. It doesn't correspond to the prediction. You can just shuffle it under the carpet.
One would hope that we don't do that, but the contingencies that affect our behavior, as scientists.
Anybody have any other related questions? Shawn looks like he's going to drop some knowledge on us.
I have an open science thing to respond to some of those things.
Okay,
but I'll come back to that later.
Oh, later. All right. Any other questions?
Well, it technically is later.
Yeah, it's later now. Now.
Yeah, and I think kind of going along the themes and perhaps kind of beyond in a more meta sense, I think the growing complexity of some of the methods that we're using and publishing on, some of these tools are so advanced and so niche-y that they are becoming increasingly hard to reproduce in an analytical sense, both in terms of do you have access to the analytical software, the frameworks to use that, the various parameters you use to tune or train that. I think it's becoming increasingly challenging to review these works unless you have the complete ability to reproduce some of those experiments. And in some ways, it does put more on the authors to do that, but at the same time, for reviewers who hopefully have the time to do that, you can actually rerun many of these works that are purely artificial. So I think there is a lot of opportunities for open science to kind of help, in this specific area. I don't think it's going to fix most of the things, but I believe it would help for many of these challenges.
And you can extend that same sort of logic to data analysis as well, right? So I'm thinking of higher level models, like multi-level models, where unlike conventional inferential statistics like t-tests, ANOVA, all that stuff, there are degrees of freedom that are in the control of the experimenter, right? So you, as someone who is building this model, it's not an emergent property of the model, it's a collaboration between the data and the choices that you as an experimenter are making, and being transparent in those situations, even if the general readership of a journal, especially behavior analytic journals, quite frankly, we don't get this graduate education in multi-level models very often, can be really helpful in terms of bringing those folks along for the ride.
Absolutely.
One thing that I was thinking about during, I'm going to kind of move from that. I agree wholeheartedly with that point. I think, I've been several times now that, like talking to many of my applied colleagues, trying to sell them on R, get them using R for these reasons exactly, because I think that really facilitates that type of thing. But one thing I wanted to mention that I think is kind of interesting, I've kind of turned our focus pretty quickly to the evolutionary theory of behavior dynamics, and I think that's a great example of some of the stuff that we're trying to talk about here. One of the things that's been interesting to me to sort of observe over, the past, 5 years or so are other examples of simulated data sort of coming out in JAB and perspectives on behavior science. And I think it's really exciting to me to see kind of in a different approach, for example, using the temporally weighted matching law, or RAC. Tim Shawn in his extinction burst paper, toward the end, did some I thought intriguing simulations about like the effects of alternative reinforcement rate that made very specific predictions that could be tested. I'm wondering, I guess, what others think or what you guys think about whether or not we'll continue to see that happening more. Is it a good thing? What do we do with those predictions? Any thoughts on that?
Sounds like an empirical question. So run and see what happens.
Yeah. So you think we should test? I kind of like Jack mentioned, right? Like they're putting out some of these predictions. I think, it sets up rather straightforward experiments that, could really be useful in evaluating the model, but in also kind of deciding, we have all of these alternatives available to us, all these directions forward that we could go. Those types of very precise predictions, I think, are helpful in saying that maybe this is a useful place to start.
Yeah, I mean, from my perspective, that's one of the great strengths of QAB to begin with, right? Because it can be conceptually generative in that it helps us to organize the way that we think about behavior outcomes in a really succinct manner, using, hopefully, just a few rules, right? A few free parameters. But it can also be empirically generative. So you have this model that is built on existing data, again, hopefully, that follows a few rules that capture all of the nuances of those data. Oh, but wait, there's more, right? It's making this prediction, that prediction. Now let's go run that experiment and actually do that, right? So it is a really interesting and succinct way to move science forward, right? Because again, in a lot of these circumstances, and I'm speaking from a personal experience working with some of the RAC models, behavioral momentum theory, all that stuff, some of the questions that I asked, I never would have thought to ask had I not gotten to an Excel file and messed around with 3 parameters, like, I wonder if this actually happens. I have no reason to suspect a RAC would do this, but I've been surprised before.
I'm really happy to hear you say that because it was funny in sort of preparing for this. I was trying to think, like, what does simulation sort of mean to me? And I, at least, I'm not sufficiently quantitatively savvy to look at a model and say, it probably would predict this in this scenario. I have to get in there and tinker with it to evaluate if we feed it some hypothetical data, what sort of happens. And I find that to be such a useful process. Whether or not that counts as simulation, I don't know, but it's at least a very helpful kind of example of that process. You give some data to the model and you see what it predicts. let it help you decide what to do next. Yeah, definitely.
Other questions? Can I pose a question to the audience?
Yeah, great.
So Jack, I know how you're using simulation in your research with evolutionary theory of behavioral dynamics. How are other folks using simulation in their research? How are folks using AI in their research? How are some of these broad topics impacted the way that you work as a behavior analyst and as a data scientist potentially?
There are at least 4 people in the audience that I know.
No one wants to share that they use AI.
I know I've used ChatGPT to help them produce an R graph. So.
You mean you didn't write your dissertation with ChatGPT? Dang. How are you guys using AI and simulation in your research?
I am probably one of the more conservative side. So I personally have lots of, me personally, and just to kind of air some of the thoughts I kind of had in my head for approaching this panel is, if I were to use something like a large language model to support my research, and I'm fortunate that I could run a local model with my own computing. Not everyone can do that, but for folks that are using like a ChatGPT and you are submitting data to some server to come up with a figure or produce something for you, then what does that mean for that data? Like, who owns that data in perpetuity? Is that now something that a third party owns and will use as training data when whoever volunteered their data in your study didn't explicitly consent to that? So me personally, my use cases for AI are very discrete. I find that there's really useful ways that it supports my instruction and my mentorship, and I'll use it to make like unit tests for my software. But in terms of research, I really am very limited in terms of what I would do, just out of kind of respect for that data and the specific permission someone gave me to use that data in research.
I guess I'll give my, as I kind of jokingly said, it's funny, you get all excited about learning how to code and things like that, and one thing I've learned almost immediately is how quickly students will outpace you in being good at like coding in R or coding in other languages. So that's something that's been helpful to continue sort of my development is what students seem to be learning from ChatGPT about ways we can improve our R code and things like that. So.
ChatGPT is so great for syntax. So that and writing hard emails are probably the main reasons that I use ChatGPT and AI in my research. I doubt that it would output med state notation, but give it a couple of years, I fully feel like that's going to, if behavior analysts are feeding stuff to these AI algorithms, then they have that information and they can easily use it and reproduce it and modify it in novel ways that we might not have thought about. So it could probably take my 4,000 line code for a concurrent schedule with embedded DROs. And, yeah.
No, I'm with you. I need to do some more of that myself. Yeah, I'm going to burn up my computers with my inefficient coding. But I think simulation-wise, or whether or not we want to call it simulations, I guess, is up for debate. But I, at least, in trying to extend the evolutionary theory of behavior dynamics to more clinical phenomena, that was a big thing for me and continues to be a point of interest. Certainly, like kind of skirting this line between simulation and AI and whatever we may want to call it. So that's something that my lab continues to be interested in and to work on, trying to use that process to help us gain a little bit better understanding of clinical phenomena, especially in cases where those clinical phenomena are difficult to study or especially risky to study or to let occur at high levels or with a high degree of consistency. So I found a lot of value there, a lot of utility there. I was talking to Andy about this outside. On the flip side of things, like using it in the analytic process, I've been looking for opportunities to use things like randomization tests. I really like the 2019 paper I was telling you. I wish I saw more of that being applied and used to sort of keep the assumptions that we're opening ourselves up to a smaller level, or keeping it a little bit closer to the hypotheses we actually want to test. So,
and I think that brings Suzanne.
Oh no, I was just going to open myself up to potential criticism and give a use case. I've been analysing some survival functions. And it happened that people did 2 sessions. So you can't just throw everybody all into the, you need to do some other things to the data and think about frailty and such like. But I didn't know frailty was a term, so I started fooling around. Like, I knew it was survival analysis, and I knew I couldn't just treat every data point as independent. And so I started searching for what are the terms that I need to use to describe this problem to our statistician. And I found AI useful for giving me the language, because I knew there was a problem, but I couldn't articulate it, and so I found that useful.
Sounds useful to me.
Can you say a little more about what a simulation of an applied behavior problem would be?
Yeah, so I have only experience doing this with ETBD, so I can't speak much beyond that, although I know Shawn has done some stuff that sort of is simulating in a different way to inform your applied work and power
More
analysis.
traditional statistical.
Right, but they still count as simulating to help us understand applied problems. My interest that I was sort of alluding to related to severe challenging behavior, specifically topographies of self-injurious behavior that seem to be automatically reinforced. They kind of produce consequences that facilitate their own persistence. And that proves very difficult to try to study. It's very treatment resistant, things like that. Automatic reinforcement as a concept is also quite prickly because it gets very difficult to measure or manipulate. So one exciting opportunity, I was attending Jack's lab meetings, and just from all of the great information they were throwing out there, we were able to kind of come up with this connection or make this connection where even though we can't manipulate it or measure it very readily in clinical populations, something we could really readily do is set up a model with ETBD, the artificial organisms. We could sort of imbue them with automatic reinforcement and manipulate characteristics of it, like the value or magnitude, and see if they produced responding that mapped on to patterns that we expected based on clinical outcomes. Does that sort of help? But
I think what you all have been saying is then you'd circle back and someone would have to test it in reality. And it's just a question of how far do you go, who's going to test it. As we all know, when he gets it wrong, it's so wrong.
Yeah. No, that's a good point. So we alluded to this, Jack kind of mentioned it, at sort of 2 stages here, where there's available data and we're trying to see if the model or the theory can produce data that align well with that. I feel that is one level and a safer level to operate in. Whereas the level that you're alluding to, or the second stage prediction that Jack mentioned, is where we're going beyond that safety net and we no longer have data with which we can readily compare. So in the case of the applied applications, we benefit from the arduous, extensive data collection that applied researchers have done to really characterize these subtypes and different patterns of responding. So in that case specifically, I felt a little bit more comfortable because we had reams of clinical data to build our case on. But in those predictions that extend beyond, I agree it's important to be cautious and to ensure either we or someone follows that.
Don't try this at home.
Yeah, exactly.
The other comment that I would provide relevant to that question is that the translational research machine is also really, really helpful in these circumstances. So I think the literature on persistence and relapse is a great case in point because we have several models to choose from. Sometimes they make competing predictions. Our first jump is not to say, okay, we have this very specific prediction of this model. Does it work with kids with clinically indicated behavior? Or does it work in a situation where, someone could potentially get hurt if this prediction doesn't pan out? So I have the good fortune of having an animal lab. I do some stuff with animals. Oh, look, it happens there. Move it into people. it works with college students responding in arbitrary situations for point reinforcers, and then we slowly, and when clinically indicated, move that into clinical situations. So it's not, it's not a fast process, but going back to what you're saying about having to keep safety in mind and use not only simulation, quantitative modeling, all of that stuff, but also all of the wonderful things that we can accomplish as a broad field of behavior analysis and all of the different research domains where we can practice and can conduct research to maintain safety and make sure that what we're doing is going to actually help people.
Because just for the sake of doing it, that's not our world quite so much.
Right. Yeah, just to add on if I can, I think it's such a good point, like especially with the translational research process, I appreciate that so much. I think one thing I just want to make clear, at least about my own perspective, maybe speaking a little bit to the issue that Suzanne mentioned at the beginning, like simulations in the absence of data may not be very useful to us, is sort of my opinion, or at least despite the utility that simulations may have, they'll never be anything without subsequent experimentation. It's sort of useless to us without that follow-up. So I think it can be helpful to guide or to orient or inform, but not without the experimental piece of it, for sure. There's a hand back there. Yeah, go for it.
Hi. With regard to procedures that are already empirically validated, what is your take on, I've seen a lot of talk online about can AI replace behavior analysts in some settings? Can it do the work for them? I don't agree with that, but I'm interested in what your take is.
There's a point I wanted to touch on. I've tinkered a little bit with like trying to see how well ChatGPT would make like an inference from data, and I think that's where the analyst is really useful, and I think right now, at least for the ones I've tinkered with, it tends to struggle in the gray area where we typically work, and I think visual analysis is just one of those things that we haven't found a great way to just make a model for, because there's so many layers that I don't think are really appreciated. It's not like if we could treat it like an effect size, a functional relation is going to take into account your judgment of like internal consistency and other measures of reliability in your data, and I don't think it's quite there yet. So I don't think that there's any shortage of folks rushing there to be there first or try to put some product of questionable value out there. I think there are people doing that, but I don't think the models are good enough yet.
I think it's a great question. If I can just add real quick something I think is sort of relevant here. One of the things that certainly AI can and will only get better at doing is, like if we think about training situations, and that's so much of what behavior analysts do, is like learning how to assess or intervene upon behavior. But those are very social, like human problems. We're interested in the occurrence of behavior in a social context in reference to other people. And we're always going to need, I think, maybe this is too bold of a prediction, but I think at least we'll always need another person in there at least to make the training stick, or at least to evaluate whether or not it was successful in the end. So maybe not as many of us, but some behavior analysts will always be a piece of the equation. That's my hope, at least.
There are folks out there who are evaluating the utility of robots, not in a very limited capacity at this point, right? But it's the utility of robots for things like caregiver training or staff training, and the AI there is, it's not quite there. All of these studies so far have had either some degree of human control or some degree of very, very rudimentary programming where if something unexpected happens, you're done, right? But I don't know. Maybe iRobot, the future is now, right?
There does seem to be small niches where I think is really making a lot of headway. And I think there's a small area that I'm working with some folks to try to use AI to kind of streamline some of the things that we do, like interviews and general descriptive things that we do with families. If there is a chatbot-like interface that takes some of the overhead of doing effective behavior analytic work of us. I don't think that replaces a behavior analyst, but that may be something that we may be able to delegate in like a sensitive way, as that matures.
Sorry, I'm over here cracking up. Has anyone gotten onto like fake AI interview TikTok?
Yes.
Yes, right. So this is, I turned you on, Chris. So clearly AI isn't quite there yet, but the fact that they're exploring the boundaries of where this technology can be applied indicates very clearly that if it can't be applied there now, they're thinking about it, and it will be able to be applied there at some point. But I mean, going back to this idea of the social aspect of treatment being such a critical component, I don't know that we at any time in the near future will be at a place where interacting with a robot is the same thing, or from the perspective of the individual receiving the services is the same thing as interacting with a human. And especially when you're working in the context of assessment and treatment of behavior disorders in kiddos with autism who have social deficits, and that is a goal of the programming, is to increase social functioning. I think you have to be very, very careful with the way that you approach those treatment situations.
It's funny, I feel like a bit of a hypocrite because just the other day I was talking to somebody about like using the chatbots as like helping them learn to navigate social media and like respond when somebody says something, like get into a conversation and find shared interests. But that still feels, that's one step, one helpful component, but not enough to get them where they're actually conversing or able to do it when they're face to face with another person.
You've just reminded me of, is anybody familiar with Baby X? Baby X is an artificial intelligence baby, and Baby X is being used to mimic a baby, but so that the researchers can do experiments looking at the behaviour and the reactions of the parents to this this very realistic baby that cries and laughs and does all those wonderful baby things. So I think that maybe there might be some scope there to think outside of the box.
Yeah, no, I think that seems like it's closer than we all just thought it was, you know. That seems like it could be very useful, though. It's, again, in a circumstance where safety and the risk of doing it wrong is so important.
I'm currently looking into using AI to help me code video recordings of conversations, so I research on verbal behavior. Do you have any suggestions on what kind of AI might be helpful?
I know some folks.
Talking to, how long are they talking, how often are they nodding? So it needs to have the acoustic, the verbal part, as well as the non-verbal part.
I know that some folks, unfortunately I was at a conference last week where some folks were trying to do single case design and bringing qualitative elements to that as well. And I think folks have found that a lot of these tools are really useful for the transcribing aspect of that work, which is tons of work. I did one qualitative study ever. So much work. I didn't want to code those again. But at the same time, I don't think the technology is there where it extracts themes in as evenly as a way as the more mature software that's out there. And I think in each of these models that are trained, they each have their own susceptibility of bias in terms of kind of what they pull from there. So I think in some areas, it's probably more there and ready. But I don't know if I'd be ready to use that instead of a more dedicated tool for like a thematic analysis and themes.
What about the quantitative aspect, just like duration of speech, who is speaking to whom, how long, how often are they nodding?
I think the folks that I heard, it's pulling the right words. I'm not sure if it's pointing who is like question person 1 or question person 2. That I'm not sure. It's a good question.
I'll say, if you do figure it out, please let me know. Because right now we're doing similar work and just persisting on the work of a large army of undergraduate students. So they would be happy to know if we could figure this out. But I, so far, have failed to do it. I can get transcription, like Shawn alluded to, but syncing up duration of speech as well as what is said and the orienting, like to whom you're speaking, couldn't get all those pieces together. But I would love to be able to. I haven't figured it out.
But where would your undergraduates get all of their research credits?
That's what I tell myself. That's when I give up and I say, I'm not going to be able to figure this out. I remind myself of how useful it is.
But Karsta, I think like that's an excellent example of how social interactions are so complex and contextualized, and it's more than just transcribing. AI AI can do that left, right, and sideways, and as well as track movements and categorize movements into discrete clusters. I'm thinking of Deep Lab Cut, which is a free open source software that you can.
It doesn't have the acoustic part, right?
Right, and
the non-verbal part is covered with that, but
then you would need something that's tracking acoustics, something that's tracking orienting, something that's tracking gross motor movements, and here's the hard part, I think, integrating all of that into a solid understanding of that social interaction. And as someone who is socially awkward, right, I don't conform to a lot of the social norms that you have in a conversation, like I'm looking over here, right? But you can still tell how I'm, from the rest of the context in which I'm behaving, how I'm conversing, and I'm not sure that there's any AI right now that can take all of those context clues and integrate them in a meaningful way.
The thing that's especially tricky, at least in my limited failed attempts at doing this, like you, I think, and others, when we've defined speech in those like social matching studies, it's always like very operational, very concrete, like just an audible sound and things like that. Whereas essentially, I think with the transcription piece, it's really good at picking up real, like clear words. But those things that at least my lab has been recording, where somebody says, "Yeah, oh, yeah," that kind of stuff, never comes through in the duration measures or in the transcription. But it seems to me, at least, to be such a key part of what we're trying to get at with the social interaction. So it's an interesting problem. Oh, 3 hands at once. Go for it.
Okay, I remember. Maybe 20 years ago, there was Auckland research where they had a rat as a robot. It was a robot
Sniffy?
rat. And it had levers on it, and they were having it react. And I don't know whatever happened to that research, but it seems like, then I was thinking of Parlo's monkeys, something along those lines. But this idea of robotic animals to interact with animal subjects.
It's just a thing for NIH now, trying to pursue the artificial animals to get out. You might be better able to speak to that, but that sounds like that's something that folks are exploring more.
The thing that I keep coming back to with that area of research is that I think that you can observe something that walks like a duck and quacks like a duck, but it might not be operating by the same principles that animate an actual duck, right? And the only thing that we can do under those circumstances is to collect data, figure out where the convergence is, figure out where the divergence is. And I am hesitant to say that that at least, hopefully in my lifetime as an animal researcher, that there is a point where those artificial organisms will supersede the use of actual organisms, because you can have two things that look the same, but it could be similar to a case of convergent evolution, right? So bugs fly, birds fly. They don't have a very recent common ancestor as the explanation for why they both fly. They both experience similar selective pressures, right? And voila, same answer, because it's a good answer. And I'm wondering if, I don't know, I wouldn't conduct research with Sniffy and try to publish that in JM, but...
If you could conduct research with Sniffy, then arguably we would all be out of a job, right? We would already know how to program that rat to behave like a real rat.
But I think we still, I don't know that we would still be out of a job, because Jack's point earlier, right, the need, especially when you have organisms that are generating novel behavior that you haven't seen before, the need is to then demonstrate, oh yeah, this also happens in actual organisms, right? So we might have a more diverse job. I don't know, I'm just telling myself this so I can sleep at night.
Me too.
I think there was one other person with a question, yeah.
In Dr. Cox's lab at Endicott, we're looking at exploring using machine learning to understand the nonlinear dynamics of responding in probabilistic schedules of reinforcement, using actually data collected in Dr. Sanabria's data set from 2009 to 2010, and to see if we can kind of review those nonlinear dynamics and then predict IRTs inside entry using machine learning techniques.
That sounds really cool.
Yeah. And I mean, that sort of research is very important, right? Because if you are able to start to take those approaches and generate novel predictions, generate novel insights about an underlying behavior process that we couldn't have easily gotten to if you were toiling away. Longitudinal research with non-human animals or with people, just it's longitudinal. It takes forever, right? So to generate novel findings or to test novel predictions is time-consuming. It takes manpower. It takes money. But if you're able to use that as a first approximation and say, hey, here's a fruitful direction to go in. You don't need to shoot in the dark. It's so helpful, so helpful.
I don't know a great deal about it, admittedly, personally, but Shawn has convinced me at least that it could be incredibly useful with our increasing interest in basic and applied work, sort of looking at individual differences and characterizing who's who, using machine learning to help us identify clusters of different response patterns and things like that. So I see that as a really exciting, kind of future path forward. So great that you guys are doing that.
And I think that's a really fruitful area to explore, because I think machine learning is one of those nice areas where you have the opportunity to leave from this idea that most of the things that we're trying to measure are stationary, and we know they're not. They're going to change over time, and with machine learning, that's just a new tool that we can use that's going to not have that assumption, which we all know that's not a safe assumption anyway. So I think it's a great direction to be going in.
I think we might have time for either one more question or our discussant wrap-up.
So I was actually more interested in what people thought about replication. So maybe you've coded some things using VCut. Sometimes we use iterator reliabilities as measures of not just reliability and your confidence in those data, but also a sort of a sense of, is there a grey area in the data? And so I'm wondering if we use these tools to classify data, do we care about replication and iterator reliability, or whatever the appropriate term would be? This is kind of a JAB issue, so what's the guidance that we want to give to authors? You need to run things twice, or...
I think oh, go ahead. I was just going to say what you said.
And I think what gets really interesting, and admittedly the ATBD stuff I haven't dug in quite as much as you have, but there's so many options and parameters that are all not forking paths, but lots of latitude for a researcher to use. And I think, I don't know if this is a replication thing, but it would be nice in research to have some confidence that it's not just this one magic combination of parameters makes it all pretty, and that there is something like a sensitivity analysis where across various conditions we're generally converging on a similar idea of where things are going to land. And I think that there's a space for that work, and I think that would only kind of serve to kind of boost confidence in just how much you would feel that you would want to invest in empirical work kind of validating these predictions if it looks like it's sufficiently robust.
I thought your open science point, just more generally kind of gets at the heart of it, where just providing the code so people can rerun the analyses themselves. Reviewers who are so worried about it or wanting to ensure the rigor of it can go into it themselves.
I think most reviewers run that code.
Oh yeah?
If you submit code to your submissions, I'm pretty sure the reviewers run it.
Well, yeah, we have to submit it though. That's what I'm getting at. Chris? Go for it, Chris.
It is officially the aim. We could probably push it a little bit, but we may be kicked out at some point.
I actually have to do something else.
Okay,
Sorry, Chris.
thanks, Ron.
I want to hear your question.